welcome everyone to the third module for the data management course provided by Statistical. So this third module will be focusing a bit more on some of the technicalities around sort of your data and data management. While we've called it data management in R, as you'll see that a lot of the post-session workbooks and the materials will be focusing on how to do some of these techniques within R. Of course, remember that R is not your only option when it comes to working with your data. So many of these same principles and techniques will apply to whichever system you are using. It's just that to demonstrate these practicalities, we have chosen R to focus in on. That being said, the sessions themselves, these live sessions like this one, they aren't too focused particularly on R code and things like that. So you won't really see much in the way of R code within the live sessions. However, we have developed some workbooks that I will explore a little bit towards the end of this first session, which will demonstrate some of these concepts more closely and specifically show you how to do certain things within R. So this first session for today is focusing on this concept of tidy data, which is something we will explore for most of the first session, and I will help explain what it is and what it means and why it's something you should be thinking about. And then towards the close of this first session, I will be looking a little at something that is a bit specific to R, which is something known as projects. So I'll show you I'll show you what they are, why they're useful, and sort of how to create one as well. So as I say, this first session will be focusing on tidy data. Around Q3 East Africa time, we will take a bit of a quick break and then just 5 minutes, and then we will then start on the second session of today, which we're looking at the difference between some data shapes, which is the difference between what's known as long data and what's known as wide data. So I'll show you the differences between those and how the different varieties are useful. But starting with the tidy data and projects, today's learning objectives is that I would expect that by then that hopefully you'll be able to sort of know how to create your own project folder directly within R that can be very useful for your data management needs. I would hope that you understand the rules regarding tidy data, or at least the principles and recommendations around tidy data. Also distinguish what makes a good column name from a bad column name. That'll be something else we'll look at. And then, as I say, after the session, there will be a workbook that will be accessible on the course website. There'll be one for each session. And these will explore the technical aspects of some R code, which would be useful for this first session. It will be a workbook that's useful for helping you know how to clean some of your data within R. So what would we mean by data tidying or data cleaning? So I forget who said this, but someone always says about data scientists spend up to 80% of the time on data cleaning and only 20% of their time on actual data analysis. I think this is quite a true statement when you look at it, because data is rarely perfect from the start. Even if you've sourced it from elsewhere, you'll find little mistakes that maybe have gone missed, or there's certain things about that data that don't suit your particular needs with how you need to use that data. Or maybe if you're using ODK, for example, perhaps there's certain things about how the ODK form was conducted that means there's some errors in the data, or again, certain things don't meet how you need it to use it straight away. So we've already seen in previous modules with sessions on data quality and insurance, just how important data cleaning can be. and just how much sometimes this can equate to and how much needs to be done. Certainly some of the cleaning process you might find easier in Excel. I think that's perfectly valid. There are certainly some things that would be quicker and easier in Excel, sorry. But this module will be focusing on perhaps some key issues where maybe R might be the better option. So data cleaning, it can be tedious. I think we all know that, but ultimately it is one of the most crucial aspects of your project workflow, because you really need to make sure that that's done to an appropriate standard to make sure that your eventual data analysis also goes smoothly, because otherwise you might get to the data analysis stage and realize, oh, we missed that in the cleaning and we need to go back, or errors might be missed in the cleaning and they're not even spotted at the analysis, and then there's technically errors in your analysis that you haven't noticed. So the end product of a data cleaning process should always be what we would call tidy data. So tidy data, this is a concept drawn up by a quite relatively famous R developer known as Hadley Wickham. So he prescribed a set of guidelines for the arrangement of your data. And he described it as tidy data sets provide a standardized way to link the structure of a data set, its physical layout, with its semantics, meaning its meaning. So the structure being the form and the shape of your data, semantics being the meaning. So it's a collections of values organized into variables and observations. So there are certain rules regarding tidy data that we would consider. So each variable will have its own column. Each observation is itself a single row, and every cell is a single value. So there's no sort of crossing of wires where you have some variables that got into rows, or there's multiple observations in a single row, or there's sort of crossing of values into single cells in some way. So the point of tidy data is basically to combat what we would simultaneously call messy data. And there's quite a lot of ways in which data could be considered messy. So for example, something you do see quite a bit when the data you have taken was designed for presentation rather than analysis is that you will find that column headers are more values and not explicit variable names. So if you see in this top example of the three here, what you'll see is that you have rows for the observations which are different religions. And basically this is a table of frequencies. So what we have along in the columns is that each column is a grouping of income. But of course, this has then resulted in being that we have these column names which are less than 10,000, 10 to 20K. These are kind of income values in themselves, and perhaps not great for naming our columns. For one, they aren't good column names. But you can see how this would be a better suited shape for presentation and not necessarily for analysis. For analysis, to basically make this tidy, what we would prefer is we would still have that column for religion, but so just a reminder, what if they can keep their mics muted? Yeah. And preferably then we would have another column which would be income values. So basically these income values would now take a new column as a variable for income, and then the frequencies would be a third column. Essentially, that is an example of what we'll get onto in the second section, is that what we have here is an example of wide data. And what we'll see is that to make this tidy, it would be moving it into a long data format. So that's something we will explore more in the next section. Another common issue you might find is that we have sort of multiple variables being stored into a single column. So this is something you can see in the bottom left piece of data here, is that so you have this column for the year, that's fine, it's all the same thing. But then you have this demographic column, and what that is showing is both the gender and the age group. So it's sort of holding more than one piece of information within the same column, and quite often that's a bit unnecessary, arguably. So with fixing something like that, it would be finding some way of separating out that piece of information into individual columns. So we have one variable in one column, rather than in this example, we're having two variables in one column. And so in this example of messy Sophia, so back into this one, just to reiterate that we have column headers that are values. You can see that we have these income values, and they're being used to define these columns, when really they might, especially when it comes to analysis, those would be better suited as being a variable in their own right, rather than splitting the levels of this variable across multiple columns. So this is data that's better suited for presentation as opposed to analysis. So for the third type of problem with messy data that we have on this slide, is that we have this issue where variables end up sort of getting stored in both columns and rows. And this is what we're seeing in the bottom right piece of data. So what we have here is in this one particular area over time, we are recording the maximum and minimum temperatures. And how this data has been stored is such that we actually have been recording maximum and minimum temperature for the same day, sorry, for the same month, but in separate rows. So you see that for this month one, you have the maximum temperature in this one row, and then the minimum temperature in another row. And what we've done is then spread those recordings across each day of the month into columns. So we have a column for each day. So we're kind of recording both temperature as day, we're recording days as one sort of variable, each day as a different variable. But then we also have maximum temperature, which is a variable in itself in one row, and a minimum temperature, which is a variable in itself in another row. So, and we're getting these values of maximum and minimum temperature actually being stored in separate columns too, where we're sort of recording this as being maximum and minimum temperature. So with this data, what would be much better would instead bring that days, the number of days across these columns, bring that down so that actually our rows are each day of the year, as opposed to, for some reason, having sort of like these separate months and putting them with different rows for the temperature recording. Because also consider that not every month obviously has the same number of days. So there's going to be quite a few instances for this month, for a particular month where there are some completely unnecessary columns. So for example, for month 3, which would be March, so that's not a good example. Sorry, for month 2, which would be February, we wouldn't really need these variables D29, D30, and D31. They are completely unnecessary. So it'd be much better to bring days into the rows, because then we can filter out all those ones that are obviously not going to be needed, and then store maximum and minimum temperature as separate columns. So this is again an example of this sort of long versus wide data, which we get into in the next session, because currently this is a bit of a mess of wide and long at the same time, but it's defining it sort of the wrong way around. It's using what we should be defining our rows for to define our columns, and defining our rows based on what should be our columns. It's doing it the wrong way around. So, and then, as I say, there are 5 ones. So there's a couple more that are sort of start going onto this idea of relational data, which is something we will be covering in Wednesday's sessions. So another issue is something that we would call that there's multiple types of observational units, and they are stored within the same table. So very often it is quite common for data sets containing data that is at multiple levels of different observational units. So for example, you might have data from a farmer, but you also have data for each of their individual plots. So it can be quite common to find that they have put this, all the farmer data and all the plot data, and kind of mashed it into one single data set in some way. Perhaps they've put groups of columns for each individual plot, or they've transformed the data so that each row is a plot for the farmer. Of course, there are different arguments for which way to do that, but the more advisable way that would be less messy would be to actually have this farmer level data information in one table, and then you have a separate table that stores all the plot level information and data. So this is basically that you have data at these different units, and therefore these different units should be stored in different data tables, or at least merged in some useful way, rather than kind of perhaps keeping them a bit messy. But, so yeah, as I said, that is something we'll also explore when it comes to relational data, because these would be relational data tables in the farmer data and the plot data will be linkable through some key variables. And then so finally on this issue of sort of messy data that you might find is that you also have sort of the reverse of this issue, where you are keeping data about the same units, or like the same information stored across multiple tables, when that might not be necessary. So this is more of an issue of you're keeping the same data in multiple different places, and this just might not be necessary. I would say this is one of the less troubling issues. I would say it's more an issue of sort of, I think I saw it termed as database normalization. It's about making sure that pieces of data are only stored in kind of one place and not unnecessarily stored in lots of different places. So as I say, data merging at these different levels and looking at relation to data, that's something we will be coming back to. So sort of a similar, another area of sort of tidy data is or just generally good data management practice is to do with your column names. As if anyone here has downloaded data from Cobro Toolbox before, they might notice that if they check that box about how it sort of defines the variable names and you put it to English or Spanish or whichever language you are using rather than what's called XML values and headers, you notice you get very long column names as it puts the sort of label of the question as the variable name. So you get variables that are like question 1.5, blah, 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 whatever the full label of the question was. So you end up with column names that are hundreds of characters long and needlessly complicated. So obviously that's something you want to avoid. So an important component of making sure your variable names are effective is through these many tips. So a variable name must obviously describe the information that is presented by the variable. And also consider how easy it will be then to code within your analysis, you know, for one, remembering what it is rather than having to keep looking up, but also keeping your code quite easy to read for one and easy to write. So a column name, a good column name should obviously be reflecting the data that is stored within that variable. So something like area underscore HA, it's quite clear that that's describing some area and it's putting that into hectares, or heights or weights, and perhaps unit of measurement as well would be an alternative. So it might be heights underscore cm if it's centimeters, or in if it's inches, but basically names like this as opposed to say V1, V2, V3, which sometimes you do see, and that often requires looking at some sort of data dictionary or metadata to double check what this means, whereas you might not necessarily need to do that when it's something simple like area or height. But you also want to be quite precise about it, but not too repetitive. You don't want to keep sort of including the same information in the title to be as specific as possible. So you don't want to keep writing. So for example, if you have a data table and it is all plot level information, and it's quite clear that it's all plot level information, and if you have a variable describing the area of that, of each individual plot, it would probably be more useful just to call that column area, because you know all that data in that table is about the plot. So you don't need to say, call it plot underscore area or something like that, because basically including the word plot in the variable name at that point would be a bit redundant, because you know the data table is all about plot level information, so you don't need to put that in the name. Obviously don't write them too long. I think I've already mentioned that, but sort of say, again, with for area, write area underscore hectare and not area plots in hectares, and put underscores in between that. It's just unnecessarily long. Again, it's not good practice. Avoid using characters other than sort of letters, numbers, underscores, and periods. This is especially true if you are working in R, I will say, because R sort of is a bit funny about certain variable names as well. So it won't allow column names generally if you're putting things like colons and dollar signs, or even special characters that may have, say, accents or umlauts or something like that. So generally letters, mostly preferably lowercase, I think is also a tip I've heard, especially from data science or people that don't like capital letters. But numbers, underscores, and periods, these are sort of the things to stick to as well. And so finally, something that's also very important when it comes to column names is also using consistent standards. So, for example, say you have some longitudinal or repeated measure data. Sorry, I just noticed a typo there. Maybe keep a pattern, is what I should say, not parent, like measure underscore time points. That's another typo. So, for example, say you have some costs data from these two different time points from say a baseline and a midline survey. So you could put costs underscore 2019 and then costs underscore 2020. So a good sort of consistent pattern in the variable names to make it clear, okay, which variables are coming from 2019 and which are the measurements coming from 2020. So keeping some sort of consistent pattern so that then you can easily kind of match between those two columns during analysis, so that you're not, having to look up, okay, which one's coming from 2019 and which one's coming from 2020. Like if they've at some point in the questionnaire, perhaps they changed question number or they changed name in the ODK form. So keeping this consistency between them definitely helps with keeping your data tidy, and then will also help you in analysis. Before I go on to some R technicalities, just for a few minutes, there's anything other that's coming up in the chat or any other questions? I noticed. So yeah, as Alex just said in the chat, someone was saying about sort of what's really left once you're only really putting in letters, numbers, underscores, and periods. As really points out, you have many other special characters, especially regarding punctuation. So things like dollar signs, exclamation marks, colons, ampersands, accents, quotation marks, or even special letter characters as well. So these would be things like an A that has an accent, or a U with an umlaut if it's coming from German. Again, R isn't, or most actually statistical software wouldn't really be comfortable using those sorts of characters, and that generally, I know R explicitly, except for a few workarounds, it won't really like column names that are anything other than letters, numbers, underscores, and periods. And even within that, you can't start a column name with a number either. So really a column name within R has to start with a letter. So do we consider a raw data set as metadata? I would say it depends. So I would say generally, probably any raw data that come in would likely be in some way messy, maybe not to the extent of some examples that we saw there, but there will generally be something that needs tidying up about messy data. It might not be that you have these issues of, say, multiple variables in one column, or variables using sort of levels of a variable being used for separate columns, but you might have, say, things that are messy in a different way. So these could be things like, say, missing data or some incorrect data that you need to go in and fix. That's still part of making data tidy, but it's not as one of these sort of big messy issues that sort of those sort of 5 that we explored sort of come into. But even then, as I say, it depends as to sort of maybe how your data was collected, and and sort of how sort of managed and structured that was. So for example, again, if you are using ODK, I would say if you are quite strict about the development of that ODK form, because obviously that you can define your variable names within ODK. So if you are, for one, very strict about that, but also take quite good note of the sort of structure of that form. So how is it using things like repeat groups in particular would be somewhere where a lot of these issues come in. And that, again, that's something I think I'll be looking at a little bit in the next session. Sort of because when it comes to repeat groups, sort of depending on how you download the data with the settings, it can either come through quite messy or quite well structured. And it kind of depends on a little bit of the settings. So I would say generally raw data, you could consider it messy, but there are certainly steps in sort of the before data collection that can be taken that may reduce this messiness and make it a bit more tidy. What about the data that has been collected and downloaded in coded format? So could you just explain what you mean by coded formats? That person's still, yeah. Yeah, so Chege, what about the data that's been collected and downloaded in coded format? Could you just explain what you mean by coded format? Just give you another minute, otherwise I'll move on because I'm not. So R package. So with R packages, that's something that will be more come into play on the workbooks. But the main sort of package that we would be looking at is something known as the tidyverse. So this actually is a range of packages that you can sort of install them all at once, thankfully. And what the tidyverse does is it was actually developed by the sort of same people who came up with this idea of tidy data. So it's a range of packages, both to make R a bit more simpler, especially for beginners, but also to simplify how you do a lot of these data manipulation and data tidying steps. So in particular, from tidyverse, you have two packages, which are dplyr and tidyr, and they're both very useful in sort of data manipulation and tools that you can use to tidy your data. But as I say, package stuff will more come into play in the workbooks, and they will point out which ones are being used. I'll just move on, start explaining R while I wait for explanation on that coded data thing. So I'll come back to that once we have a response. So yeah, so just to quickly go over something that is a bit more R specific, is that we have within R something that are known as projects. So I'll explain a bit on that. But firstly, I'll just quickly go over for what is R and RStudio for people who may be a bit newer and haven't, say, done our previous R courses that we've run. So R, I think, as we know, is a useful software for statistical analysis and data manipulation. And though we can use it for many different things, even beyond statistics, even say, development of web-based apps and even learning materials, as you'll see in the workbooks, those were all created within R. So R is sort of the original sort of language and interface, and it's quite, if you go onto R, the original one, it's quite cumbersome and very outdated. So that's why people developed RStudio, which is used to sort of interact with the underlying R and make it much simpler to use and more user-friendly. So R itself as what we call an object-oriented programming language, which means sort of everything you do within R is you have these things known as objects, and these can be your data sets, your models, your just a list of values. Everything is sort of works with making changes or running functions or applications to that object, to that piece of data, to that list, to that model. That's sort of how everything works. And as I say, while primarily though a statistical analysis tool, much of the data manipulation that you can do, so cleaning and even aspects of file management, can all be integrated and conducted within RStudio as well. It's not just all about your analysis. So if you've not already done so, I recommend that you do install R and RStudio to your computer. Do that after this session. And they're open source software, so it's all free to download. But you would want to download R first and then RStudio. There are some links available through the presentation slides, and you will have access to the presentation slides on the course site. So you'll be able to install R through that. But so within R, we have a very useful inbuilt system that can aid immensely in file management. What you can do is set up what is known as an R project. And again, I've provided a link to a video and a page, sort of going over some of the basics of working in RStudio. And this includes how to set up an R project. So what a project is a really useful way of keeping your work organized when you are working in R. For one, it makes it very easy to link sort of to your input files, so your data and things like that, and also then to write out and store your output files in a sort of coherent workflow as well as like file management system. Basically, it keeps everything together in one place. And through your scripts, you can sort of, it would be writing relative like file paths to those data files, so that you don't have to put in the really long-winded ones and change it every time. So this is why project files are especially useful for when you're working in collaborative projects, or when switching between different computers, because if you do this without setting up a project file, well, you have all these scripts and your data all in the same place maybe, or in different places on the machine. That means you have to sort of keep updating these file paths that sort of import your data into R each time, because it might be saved in different places, or it might be saved on, say, a Dropbox, in which case it's using somebody else's name. Projects kind of really help in working around this, because everything becomes relative to where that project is on the system, so it doesn't need to worry about all these long, complicated file paths. So basically, a project is about keeping all your files together, and R knows where sort of everything is in that thing. So if I just open R to show you, and then I'll keep this on the other page. So as I say, you can haven't mentioned, but there's sort of two ways to open up a project. So within R, you would need to go, you always have this in the top right corner. And you can see it also is showing me a bunch of projects that I already have used recently. So we can do a new project. And we kind of have two main options here. I won't delve into the version control thing, but so you can either start a new directory, and by directory, it's sort of referring to where everything will be saved. So if I start a new one, which is maybe what you want to do if you're right at the start of the project and haven't really sort of saved anything anywhere yet. So if you start a new one, start a new project, and then I would say where to put it. So I'll just put it into my documents and just call it test one. And I won't bother with those for now. And if I just create this, and you'll sort of just restart, and what it'll do is, if you see in my documents, it's created a folder for this project. So we haven't had to create a new folder manually. R has done that for us. And if we go in there, you'll have a what's known as an R proj file. So this is the project itself. So when you open that, it kind of brings R up and kind of remembers what you were doing in regards to that project. And then within this folder is where you would now start wanting to save all of your other bits of information, so that could be scripts or data files. And sort of by default, anything you create within R will save within that folder straight away without you really needing to specify. That's where it'll go by default. And so the alternative, which may be the one you would be doing more likely, is that you're doing from an existing directory. So this is when you've kind of maybe already got all your file management structure kind of already developed, and now you're moving into R. So this would, you would browse instead for where you already have lots of things for your project saved, and just select there, and kind of the same thing will happen. It will create another new folder, or sorry, it will create a project file and put that into that existing folder. I think we might have, there we go. Something else in the chat. Can RStudio be used to include data from a semi-structure? I would say not really, no. I would say for qualitative data like that, you probably wouldn't want to use R. It can store information other than numbers, of course. It can store sort of categorical data from a survey. It can store lots of different types of data as well, because it can also use sort of geospatial data. But I would say that qualitative data from an interview or a semi-structured interview, that's not really what you would use R for. Because R is, while you can do lots with it, I don't think there's too many tools that people have developed specifically for qualitative data analysis. I would imagine that maybe in the fourth module in a few weeks' time, which is focusing on data management for qualitative data, I would imagine that Nuru might be showing off perhaps one or two pieces of recommended software that would be better suited for that sort of information. Okay, that's sort of, oh, no, there wasn't a slide, sorry. So when working with RStudio projects, it's then useful to still maintain that consistent data management system within it. So for example, it's quite useful to keep sort of data, scripts, maybe documents, sort of all in separate files. So the example here on the screen is one from one of our projects at work. So you see that we have this R project file is here in the mimic analysis, and you have the R data and R history files that always get created by R. And then what I did from there is I needed many different files and types of files for this project. So I decided to keep them separately. So I have a folder that stores all my data. I have a folder that stores all the HTML and Word documents that get produced by my analysis scripts. I had one for images. So again, this is another sort of outputs that might get created. I had a markdown, which so markdowns are a type of script that R can use, generally useful for writing up certain maybe reports or sort of commented analysis outputs. I had old/deleted for things I didn't need anymore or weren't particularly useful. And then there were scripts as well, which was kind of similar to Markdown, but that's scripts is the more traditional R format for files that sort of contain all of your code, but they don't create the same level of output that a Markdown